So in this video, let us go for this problem number 1.4. Determine the magnitude of y-intercept of the resultant of a force system acting on the lamina as shown in the figure. So here they are asking the what is the intercept, y-intercept. So how to calculate this y-intercept? For example, in the previous problem, that is solution of this problem, we have drawn something, that is there was a square box was given about which few forces were acting, and we had a resultant acting something like this. So the value of resultant was somewhere around 749.2 Newton was the resultant. So what they are asking to find out what is the y-intercept. Y-intercept nothing but if I draw some x-axis along this drawing and y-axis here, they are asking where this resultant will cut this y-axis, where this resultant r will cut this y-axis. And if x-axis is drawn, if x-intercept is asked, that is if I extend this resultant, where this resultant will meet with the x-axis, this distance is called as x-intercept, and in the y direction it is called as y-intercept. So this is how x-intercept and y-intercept are to be calculated. So since many students are asking doubt what is this moment and how to calculate moment, they are getting some confusion. So I will explain the definition of moment once again before going into the problem. So first let us see the diagram of this problem. Determine the magnitude of y-intercept of the resultant. That is, they are asking where it is going to cut the y-axis force system acting on the lamina as shown in figure. So this is the given figure. In this, a force of 200 kilonewton is 400 Newton is acting here. Another force of 200 Newton is acting here. A force of inclined force of 600 Newton is acting here. So see here, no moment is acting on this body or this system. Only three forces are acting here. So before going into, many are asking what is this moment. They are getting the doubt of what is the moment itself. So the moment is nothing but it is a rotational effect of a force about a given point. Rotational effect of a force about a given point. For example, here I am choosing this point. Let us take this as a point A, this point. So about this point, how this force will produce an rotational effect. How we will calculate that rotational effect of magnitude? The magnitude is calculated by force into perpendicular distance. So see here, because of this force, if I am choosing this point, let me write it as O or A. About this point, how the force is producing the rotation. So see here, since this force is passing through the same line of action, that is here, there is no perpendicular distance. Force into perpendicular distance is 0, right? There is no perpendicular distance. This line of action will pass through this point. There is no perpendicular distance here. If I come to this force, if I extend its line of action here, what is the perpendicular distance? Perpendicular distance is from here to here. This is the perpendicular distance and this is the force acting here. So as we know from law of transmissibility, a force can be transferred from one point to another point along its line of action. Remember this one, law of transmissibility of force, that a force can be transferred from one position to another position without one position to another position along its line of action without changing its effect on the system. That was the law of transmissibility. In the same way, what I am doing, I am transferring this force along its line of action. So force will be acting here. This force I can transfer here, this 400 kilonewton. 400 Newton. So this is the perpendicular distance. So how to calculate? So if I fix this point and this is the perpendicular distance, what happens here? Let me draw a force here. I have transferred. See, this 400 Newton I have transferred here. See, this 400 Newton along the line of action I have transferred it here. This is the perpendicular distance. If I fix about this point, for example, I will select this one. See, what is the rotational effect of this force about this point is called as a moment, and mathematically I will give force into perpendicular distance will give me the mathematical value of this rotational effect. So see here, this is the perpendicular distance about this point. See, about this point I am choosing. So see here, this arrow is rotating in a clockwise direction, or else what I will do, I will select this whole system itself because of this force. See, because of this force, what is happening? The system has started to rotate in a clockwise direction, right? In this manner, we need to calculate the. So give a still a clearer imagination of this, what I have done, I have drawn some 4 bars here. So see here, this is the fixed point where I have shown this dot. This dot is the fixed point of this bar, and the force F is acting at a distance r. Let us select this whole body. Due to application of this force, what happens? See here, I have fixed this point. About this point, the body starts to rotate in a clockwise direction. What is movement? Movement is nothing but the rotational effect of a force. Movement is nothing but the rotational effect of a force over a body about a given point. So this is the given point about which the body starts to rotate. See here, due to application of force, the body is rotating in a clockwise direction, and r is its perpendicular distance between point chosen and applied force. See here, the body started to rotate in a clockwise direction about this fixed point. About this is the fixed point. About this fixed point only it is rotating. So see here, the fixed point is there only. The body has started to rotate in clockwise direction due to application of the force. So see here, the body is rotating about that fixed point. When I apply the force in opposite direction, same, this is the same perpendicular distance from here to here, the perpendicular distance and between the applied force and fixed point, and it is given by r, small r. Select this point. So see here, due to application of force, what happens? The applied force is in upward direction. The body starts to rotate in anti-clockwise direction about the fixed point. See, the fixed point is not moving anywhere. It is fixed there only, about which this body has started to rotate in anti-clockwise direction due to application of the force. Now see here, the applied force, this applied force is passing through the point chosen. Here the applied force is passing through the point chosen. That indicates there is no perpendicular distance. This perpendicular distance will become 0, right? There is no perpendicular distance. There is no question of perpendicular distance. If I choose this here, there is no rotation produced because there is no perpendicular distance, so no rotation will be produced. Even if I move this force from here to somewhere here, Okay, I am moving this force. So what is the perpendicular distance from here to here? This is the perpendicular distance. So now what happens if I select the whole system and select this is the fixed point? About this force, what happens? The body again starts to rotate in anti-clockwise direction. If the force is passing, see here, if the force is passing through the point chosen point, then there won't be any rotation produced on the body. That's why the moment will become zero here. So movement is nothing but the rotation effect produced by a force about a point chosen. That itself is the movement. And mathematically how will express the force into the perpendicular distance between the point chosen and the force is called as a moment. This is the mathematically how we will define the moment. So kindly remember these things. If the force is passing through point of action, then it is the moment will be zero. So let us go to the problem now. So now I am choosing this as my point. See here, this 200 kilonewton, 200 Newton, when I extend this, this force is passing through this point only. That's why there is no movement here. And now let us resolve this 600 Newton. How to resolve this one? First I need to know what is the angle, either this angle or this angle. To know that, I need to calculate this angle theta. How to calculate? This is 2 meter and this is 1 meter. This is forming a triangle, right? So this is forming a triangle here. This is the triangle and this is angle theta. How to calculate? Theta is equal to tan theta is equal to opposite divided by adjacent. That is tan theta is equal to 2 by 1. It is becoming, what is the value of tan 2 by 1? Sorry, shift tan inverse of 2. So theta is equal to 63.43 is the value of theta. So this is 63.43. This is 90 degrees, right? So what is the internal line? So if this is theta, so since I have said draw a z here, so see here I am drawing a z here from here to here. This will make an z, right? Or law of parallelogram only. This is angle theta. So if I draw it like this, opposite angle, opposite of this angle is this one. So this angle is becoming 63.43 degrees. Okay, I will write it with neat manner. So this is the angle theta here. Okay, so see here what I am doing, as I taught you in the last problem. If we consider this one, these two as the parallel lines, it is a parallel line like this. So what happens? This angle will be equal to this angle. So now what I have done, I have extended this line here and this is the line that is force. So these two are opposite angles. This is theta, means this will also become theta, and if this is, let me write theta 1, then this will also be theta 1. In this manner we have to calculate the things. So see now, this is equal to theta. What is the value of theta? 63.43 degrees is the value of theta. Now I need to calculate other things, that is cos theta, sin theta, resolve this force. So upon resolution of this force, this horizontal force is moving away from the given force. So what it will be 600 sin 63.43 degrees, and this force will act vertically downward, and this will be equal to 600 cos 63.43 degrees. These are the two forces upon resolution. Now how to calculate summation of horizontal forces is equal to 400, since it is acting in right hand side direction, plus 600 sin 63.43 degrees. 600 sin 63.43 plus 400. The value of horizontal force is 936.63 is the value of horizontal force, and since it is the value positive, it is acting in right hand side direction. Summation of vertical forces is equal to, which are the vertical forces, 200 Newton and this 600 cos 63.43. Since 200 Newton is acting upward, it will be positive value 200. This force is acting in downward direction, minus 600 cos 63.43 degrees. So its value comes to be minus 68.34 Newton. Since it is negative value, the force will be acting in downward direction. If I want to know the position of resultant, the horizontal force is positive, the vertical force, summation of vertical force, the resultant will be acting in the fourth quadrant. If both were positive, then the resultant would have been acting in first quadrant. But since one force is positive, another one is negative, then it is acting in fourth quadrant. Now I need to calculate this resultant, magnitude of this resultant, and the angle theta here. So resultant R magnitude is given by under root of 936.63 square plus minus 68.34 square. So resultant R is equal to 939.15 Newton is the value of resultant. Now theta is equal to tan inverse of summation of vertical divided by summation of horizontal, which is equal to tan inverse of what is the vertical force, minus 68.34, and horizontal force is 936.63. so your theta will be equal to minus 4.17 degrees. Minus indicates I need to measure the value of theta in a clockwise direction. The theta is equal to 4.17 degrees. Value of theta is equal to 4.17 degrees. This is the theta. So now let me draw this resultant. What is the magnitude of resultant? Magnitude of resultant is 939.15. So this is the value of a resultant, 939.15. So let us assume this resultant is acting somewhere here. Let this be the perpendicular distance. Let us take this resultant is acting here. So perpendicular direction, this is the resultant. So let us assume somewhere this resultant will cut my y-axis. This is the y-axis and this itself is x-axis. It cuts the y-axis somewhere here. I don't know, it may cut here or somewhere else. So this is the resultant. So this is the perpendicular distance R, and this is the resultant whose magnitude is equal to 939.15, and this is the angle theta, right? This theta, that is with the horizontal, this resultant is making an angle 4.17 degrees. With horizontal, this is making 4.17 degrees. So since see here, this line is perpendicular to this one, this angle is 90 degrees, right? We know that this angle is 90 degrees. So this is 4.17 is the value of this theta now. So see here, if I draw a parallel line here parallel to this, that is this angle is equal to 4.17 degrees. So these two lines are perpendicular to each other, right? This one and this one are perpendicular to each other, that is from here to here it is a 90 degree. So if I remove this 4.17, I will get what is this angle theta. So see here, this is 90 degrees, right? These two lines are perpendicular to each other. This is 4.17 degrees. If this is 4.17 degrees, out of 90 minus 4.17 will give me this theta. So what is 90 minus 4.17? 90 minus 4.17. So this theta will come to be 85.83. So what is this R value? We need to find out. If I know this R value, I can find out this intercept. How to find that R value? So R is this force, we haven't found out. So what Varignon's principle says is the moment produced by this resultant about a system, about a chosen point is equal to the moment produced by all the forces about this point O. So what Varignon's principle says, R into R, that is moment produced by resultant about a chosen point is equal to moment produced by all other forces about that point. So see here, what is our resultant? 939.15 is resultant. I don't know what is this perpendicular distance R. What is F1? F1 is, I will take this as 400. So this 400 into perpendicular distance. What is the perpendicular? 1 plus 1 plus 1 plus 1. 4 is the perpendicular distance. 400 into 4, it is a clockwise moment. If I choose this point, this force will make to rotate this drawing in clockwise direction, that why I have taken clockwise. Next is this force is acting upward, but since it is moving from the point of action, the line of action passes through the point chosen, that's why this force will become 0. If I consider this sine 600 sine 63.43, this force is also passing, its line of action also passing through the, that is if I shift this force, what happens, this 600 sine 63.43 is also passing through the point of action. The line, this force is passing through the point chosen, that's why this will also yield no moment, 0 moment of this force and 0 moment due to this 200. Now let us come here, 600 cos 45. What is the perpendicular distance from here to here? It is 4 meters is the perpendicular distance, and this is the value. And this, because of this force about this chosen point, what happens? It will produce an clockwise movement. So at least in childhood you might have used this instrument. Okay, I will use this instrument only to explain here. So let us see here, I have kept the first point on the chosen position. So next point on the where the force is acting. So force is acting in downward direction. So see here, what is happening if I move due to the application of this force, it is rotating in a clockwise direction, right? It is producing force in clockwise. Here it started to rotate in clockwise direction due to application of this force. So this is acting in clockwise direction. So symbol plus what is the value? 600 cos 63.43 degrees multiplied by 4. So if I simplify, what is the value of R here? R comes to be 284.6, sorry, not 284.67, let us calculate this one. 600 cos 63.43 into 4 plus 400 into 4 divided by 939.15. So value is resultant R is equal to 2.84 meters is the value of this resultant. Resultant is acting at a distance of 2.84 meters from this point. So see here, I know this resultant. So let us consider this is becoming a triangle. O, I will write it as A and I will write it as B. OAB is making a triangle here. So y-intercept is nothing but the hypotenuse. Anything opposite to this angle 90 degree is taken as a hypotenuse, and anything about the known angle is taken as a opposite. This will become opposite here. This is the known angle. Opposite to this face, this is taken as opposite, and where the 90 degrees is there, opposite to that hypotenuse. In triangle OAB, from triangle OAB, what I can do? So I want to know what is the value of hypotenuse. I know the value of opposite. So what I will do? Sin theta is equal to opposite, that is OB. OB divided by OA. Opposite divided by hypotenuse. So I want to know the value of this OA, right? OA is equal to OB divided by sin theta. So what is the value of OB? OB is equal to 2.84 divided by sin 85.83. So OA is equal to 2.84 divided by sin 85.83. So what is the value? So OA is equal to somewhere around 2.84 only. So 2.847, some we can take it as 2.85. So this resultant is cutting this y-intercept, that is 2.85 is nothing but somewhere around here. The resultant is acting like this, and this is the value 2.84. This hypotenuse is making 2.85. In this manner you have to calculate the y-intercept. So till now we have solved a variety of problems. So what are those? See here, in the first problem we have found out the resultant and its position on a given bar. In the second problem we have chosen something like this. There also we have found out resultant and its position. In the third problem we have found out resultant, and upon finding out that resultant we have found out what is equilibrant. And this is the fourth category of problem where we need to find out intercept, that is x-intercept and y-intercept. So in this manner these are the somewhere around four category of problems. So this is the completion of this Varignon's principle. So if any doubts are there, kindly ask me. So four varieties of problem. One is resultant and its position on the given bar. Next is resultant and position for such kind of things. And one more thing we have calculated is resultant and the equilibrant. In this fourth category we have calculated what is the intercept. So to make you people a bit comfortable, I will solve one more problem on this Varignon's principle. Thank you.